Hi, and welcome to Isomers. To start our study of isomers, we're just going to look at some isomers. So you're somewhat familiar with naming a lot of these compounds, identifying their molecular formulas. So if we look at the first compound up here, you can count the carbons. There's 8 of them. And then if you count your hydrogens, you're going to find out there's 18 of them. And if we name this guy, this nice straight chain alkane, we'd call it octane. Now the next molecule up here, if you count your number of carbons, then your number of hydrogens, you'll find out that this molecule actually has the same formula. Now, if we look at what the name of this compound would be, however, it's a little bit different because now we only have 7 carbons in a row, and then we have this little branch up here. So this molecule does look a little bit different, and we would call this 2-methylheptane. So it has a different name, even though it has the same stuff in it. What you're also going to notice is just by changing the length by 1 carbon and putting that branch on there, look at the change in the boiling point. The boiling point actually dropped to 116. Now our next molecule up here, if we look at it, again, 8 carbons, 18 hydrogens, no surprise there. This molecule just has that one branch that we actually just moved over 1. So if you want to compare it to the molecule above, we just have a branch we moved over 1. So now it's called 3-methylheptane. But look at the change in boiling point. How weird, it went up 3 degrees. Now, spoiler alert, if we look at every other molecule on this page, believe me or don't believe me, if you don't believe me, count them yourself, all of these molecules have that same molecular formula of C8H18. But they do have a variety in how their branches are laid out. So the next molecule up here is 2,3,4-trimethylpentane. Now this molecule is much shorter than the others that we talked about before, and it's almost got like a spherical arrangement to it, which drops its boiling point down to 113. 2,2,3-trimethylpentane is another highly branched short compound. It has a pretty similar boiling point to the one above it. We have on the next one, we actually have a 2-carbon branch chain right here. So we still have that pentane base because we only have 5 carbons in a row. One of our branches is an ethyl, the other is a methyl. That actually gives us a very low boiling point. And our last molecule up here, 2,3-dimethylhexane. So all of these have the same number of carbons and hydrogens, but a little bit of a different layout. That different layout actually affects the boiling point. So if we look at all of the following, or all of the examples on the page before, what makes them the same is the number of carbons and the number of hydrogens. What makes them different is the layout, which leads to them having different names. Those compounds are all isomers. Isomers are compounds with the same molecular formula, but a different structural formula. In other words, same number of each type of atom, but a different arrangement or layout of those atoms. Because of the different structural arrangements, one of the things that we notice on that side is we have different boiling points. So we're going to have different physical properties. This can actually affect things like solubility as well. These molecules also, some of them react a little bit differently. It actually affects their reaction rates and some of the products that they can make. So they're actually going to have different chemical properties as well. One thing I do want to point out about isomers is that they do not have to be hydrocarbons. As we begin to talk about what are functional groups, we'll look at compounds called alcohols versus ethers. Ethanol is drinking alcohol that once you're 21 you can legally consume, and if you consume it in moderation, you can be around it with a good deal of safety. However, everybody knows how fun safety is. However, if we look at a molecule called dimethyl ether, which also has 2 carbons, 6 hydrogens, and 1 oxygen, just by that oxygen being moved into the middle of the molecule, we get very different properties. If you were to breathe in ether, you would pass out. That's not going to happen around ethanol. So it's important to keep in mind that isomers are a different arrangement of the exact same stuff, and that different arrangement gives us different properties. Isomers can be hydrocarbons, but they can also have what we call functional groups as well.